Today we're going to shift gears a little bit. Instead of looking at functions and tables and graphs of those functions and talking about domain and range, we're going to look at problem-solving strategies. So again, this is a very foundational piece of Algebra 1 is understanding how to set a problem up, knowing what the variables say about that problem, and how to work through those problems to obtain the solutions that we're looking for. So 4 examples for today. Let's jump in with our first one. This one focuses on understanding variables and labeling them. In the game Monopoly, you're going to purchase 4 houses and a hotel on Illinois Avenue for a one-time cost of $750. You will earn rent of $1,100 each time another player lands on your property. If n players lands on Illinois Avenue, then your profit is given by this function. P of n is equal to 1,100n minus 750. Let's start by explaining what each one of these variables means. So we have n and we have p of n. Now, n is going to simply represent the number of players that lands on your Illinois Avenue. All right. P of n then is going to be the profit that is earned. So profit earned from those players. Now, if we were to ask you which one of these is the dependent variable, hopefully by now you're getting to the point where you'd say P of n depends on n. Your profit depends on and therefore is a function of n, the number of players landing on that property. All right, what is your profit after one player lands on Illinois Avenue? So we're going to use our profit equation, and we are going to let our argument equal 1. So P of 1 is equal to 1,100 times 1 minus 750. The result there is $350. How many players must land on Illinois Avenue so that your profit is at least $1,500? So now this is a different verb that we have to put in there, right? If you remember our verbs, equal sign, greater than, less than, so on and so forth. We want our profit to be at least $1,500. So that is the minimum. Whoops, and I drew my inequality arrow the wrong way. So we want $1,500 to be less than or equal to the equation 1,100n minus 750. Now we're simply going to solve this equation backwards to get n by itself. So we're going to add our 750 over to get rid of it from this side here. And that gives us 15,750 is less than or equal to 1,100n. Dividing both sides by 1,100, gives me an n value that has to be greater than or equal to, I'm going to check my notes here, it is 14.3. Well, that represents the number of players. Now, you can't have a decimal player, so you have to say, really, the n value here has to be greater than or equal to 15. You need to round that up to the next whole number of player. All right, let's take a look at example 2. And really, the remaining examples all center around this property known as the distributive property. And you guys have learned the distributive property before. It simply goes like this. For all numbers a, b, and c, c times the quantity a plus b is going to be equal to ca plus cb. Well, let's get a look at a word problem that involves a distributive property. You just received $50,000 inheritance. Woohoo! You decide to invest some of that money in a certificate of deposit, also known as a CD, and it earns 6% interest. The rest of the money is going to be deposited into a savings account that earns 4% interest. If X dollars are invested at 6%, then the function E of X, which is given by this equation here, gives you the interest earned after 1 year. So let's just make sure we understand our variables. X equals the money invested at 6%. Okay, that's your CD. And then E of X is the interest money that's earned after 1 year. All right, now let's talk about the distributive property. We want to earn $2,500 in interest. In other words, we want our value for E of X to be $2,500. How much money should be placed in each account? All right, so let's start by setting up our equation, and we are going to substitute 2,500 in for our e of x. All right, so we're going to write it just like this, and you'll see where that distributive property is going to come into play. We have $2,500 is equal to the amount of interest earned in one account plus the amount of interest earned in the other account. Well, you see that we have a 0.04 out in front of the parentheses here for 50,000 minus x. We need to distribute that 0.04 into that set of parentheses. So our next line will read 2,500 is equal to 0.06x plus 0.04 times 50,000 is 2,000 plus 0.04 times a negative x is negative 0.04x. All right, now we're down to just addition and subtraction. So we're going to combine our like terms. Be careful, these are on the same side of the equal sign. So we're just simply going to combine them by adding them. 0.06 and a negative 0.04 combine to give me 0.02. All right. Our final couple steps here is we're going to subtract over our 2,000 to get 0.02 by itself, and that leaves me with the equation 500 is equal to 0.02x. Dividing both sides by 0.02, whoops, that's a 0.02, is going to give me the amount, we're going to write it right over here, of $25,000. All right, so there is your value for x. Now x, remember, was the amount of money that was invested in the 6% account. Well, that was $25,000. What was remaining was if you take your original inheritance, 50,000, and you subtract your 25,000, the remaining amount is also 25,000. So you would get that these two accounts both had a deposit of $25,000 in them in order to earn a total interest of $2,500 in 1 year. All right, our next example has to deal with fractions and the distributive property. Now, a lot of people don't like dealing with fractions, so we can use this technique to clear a fraction. Now, in order to clear a fraction, what we're going to do is we're going to multiply the entire equation. I'm going to circle that entire equation by a common multiple of the denominators. So here's our example problem. Suppose during the 2007-2008 regular season NBA games involving the Boston Celtics, Kevin Garnett scores a third of Boston's points. Ray Allen scores a fourth of the team's points. The rest of the team scored 60 total points. We want to write an equation that models this situation and then determine how many points the Celtics scored. All right, so our variable here is going to be the number of total points scored by the Celtics. All right, now our equation is kind of hidden here in the wording, but we know Garnett scored a third of those total points, so we can write that expression as 1/3 of x. Well, he's on the same team as Ray Allen, and Ray Allen scored a fourth of the team's points, so I know that's 1/4 of x. So together they scored that many points, plus the remaining number of points was 60 from the rest of the team. Well, together, if we add up Garnett's, Allen's, and the rest of the team, we should get the total number of points scored by the Celtics. So here's this gnarly equation with some fractions in it. People don't typically like to deal with fractions, so what we're going to do is we're going to clear that fraction out by multiplying through the entire equation by a common multiple of those denominators. So if I look at 3 and 4, smallest common multiple there would be 12. So I'm going to multiply or distribute 12 to each term of that equation. So I'm going to say 12 times 1/3, that's going to give me 4x. And I'm going to say 12 times 1/4, or 1/4 of 12, which is 3x. And then I'm going to say 12 times positive 60, that gives me 720, is equal to 12 times x, which is just 12x. So what we've done is we've created an equivalent equation that does not have fractions. That's much nicer to work with. All right, combine your like terms. 7x plus 720 equals 12x. Subtract that 7x over. And now I have the equation 720 equals, I have 720 equals 5x because I've subtracted 12x and 7x. Last thing to do is divide by 5. And when we do that, we get x equals 144. Now remember that 144 represents the total number of points the Celtics scored in that game. All right, one final example for today, also dealing with the distributive property. Now we're talking about distributing a negative. This is also known as the opposites of a sum theorem, but you'll never really need to know that. So we have a negative out in front of a parentheses. That negative needs to be distributed to both terms inside. So the opposite of a plus b is the opposite of a plus the opposite of b. Another way of saying that is negative a minus b. Let's apply that in this next problem. We see we have a function h of y. It's given by 13y minus this quantity, 26 minus 3y. We want to find the value of y that makes h of y equal to 100. So we're going to start off by rewriting this equation and substituting 100 in for h of y. All right, now you see that we have a negative in front of the parentheses. That negative needs to be distributed to both those terms, especially because we cannot combine those two terms inside the parentheses. So we have 13y minus 26 plus 3y, because we're going to take a negative of a negative, and that's going to give us a positive. Now, remember this is all equal to 100. Now we can combine like terms. I got a positive 3y and a positive 13y. That gives me 16y minus 26. Again, that's all equal to 100. We're going to add over our 26. And then finally, we'll divide off that 16. So 126 divided by 16 is going to give us a y value of 7.875. So whenever you see that that's a rational number, if it goes out to 2 or 3 decimals, go ahead and write all of those decimal values.